Hello Honors Chemistry students, this is Mr. Spurk, and this is your Chapter 10, Section 1 Notes, the mole, a measurement of matter. So chemistry is a quantitative science, which means it's based on numbers, and this means that we're going to analyze matter and perform calculations that relate different compounds in chemical reactions. So to solve these problems, we will need to be able to convert between different units. So apples can be measured in 3 different ways. At a fruit stand, you typically measure them by count. You take 1 dozen apples, which equals 12 apples. At the grocery store, they're measured by weight or by mass. They usually sell them for X number of dollars per pound. So a dozen apples is about 2 kilograms. And at the orchard, where you would pick them, so think like Lynn's Fruit Farm, they'd be measured by volume. So 1 dozen is about 0.2 bushels. Because a bushel, they're going to give you a certain size basket, and you're going to fill that basket to a certain amount. So a dozen apples is about 0.20 bushels. So knowing these quantities can help us convert between different units using conversion factors. And we've done conversion factors before. Now we're getting into the chemistry-related conversion factors. So this practice problem, we're going to figure out what is the mass of 90 average-sized apples if 1 dozen apples has a mass of 2.0 kilograms. So what we're trying to figure out is the mass of 90 sized apples if 1 dozen has a mass of 2.0 kilograms. So what we can do is figure out our starting point. Well, we want to know what is the mass. So we're going to end up with kilograms. So we're going to use our conversion factors. So right now we have 90 apples. We put that number over 1. And we know that there are 12 apples per 1 dozen. So apples cancels with apples. Now we're working with dozen. And from this problem, we know that 1 dozen apples has a mass of about 2.0 kilograms. Dozen cancels with dozen. We're left with a unit of kilograms. So we take 90 times 2.0 divided by our denominator, which is 12, and we get 15 kilograms. So 90 apples has a mass of about 15 kilograms. So now we're going to really dive into the chemistry ones. So what is a mole? So recall that matter is composed of atoms, molecules, and ions. And these particles are much, much smaller than grains of sand, and there are a large number of them in a small sample of a substance. So counting particles one by one is not practical. If I asked you to go to the beach and take a scoop of sand, and I said, "How many particles of sand are you holding?" you would tell me that I was crazy, because you're not going to try to count that high. So we want to think about counting eggs. When we count eggs, we don't usually buy them or even count them by 1, 2, 3. We purchase them by the dozen. So a dozen helps us count larger numbers of things. You can think about donuts as well. So it's easier to count by dozens than it is by individual eggs. A dozen is a specified number of things. Again, it could be a dozen eggs, a dozen donuts, a dozen apples, a dozen anything. As humans, we use grouping like this all of the time. So we're going to talk about counting with moles. So like a dozen, chemists have a unit that is a specified number of particles. This unit is called the mole. The mole, so a mole, which we shorten to MOL, you're going to save tons of time in your life by shortening it to MOL instead of MOLE. A mole is 6.022 times 10 to the 23rd representative particles of that substance and the SI unit for measuring the amount of substance. So basically, we know, I'm going to relate this back to the dozen, that 1 dozen equals 12 things. Well, 1 mole equals 6.022 times 10 to the 23rd, shorten representative particles to things. So we can have a mole of donuts, which is an absurd amount of donuts. It is 6.022 times 10 to the 23rd donuts. So Avogadro's number, which is just that number, is the number of representative particles in a mole, because there's a scientist, Avogadro, who came up with it. This is a number that you are going to get familiar with, and I'm going to say you don't need to memorize it, but you will just get familiar with it and will end up memorizing it. And tomorrow we'll watch this video in class. So a representative particle is just the species present in a substance, usually atoms, molecules, or formula units. So think in terms of pieces. So iron atoms, water molecules, H2 molecules, and so on. So 1 mole equals 6.022 times 10 to the 23rd representative particles, and we're going to use that as our conversion factor like we did for a dozen. So 1 mole over 6.022 times 10 to the 23rd representative particles, or we know that we can flip it, 6.022 times 10 to the 23rd representative particles is equal to 1 mole. So keep these in mind as we move forward. So how many moles of Mg is 1.25 times 10 to the 23rd atoms of Mg? So here's our starting point. So 1.25 times 10 to the 23rd atoms Mg. And yes, we need to write out all our units. And then we're going to use that conversion factor. So if we look back, we know that 1 mole is equal to 6.022 times 10 to the 23rd representative particles, or things. So atoms is on top, so we want atoms on the bottom. So 6.022 times 10 to the 23rd things, or in this case atoms, are equal to 1 mole. So we cross out atoms with atoms, and we go ahead and multiply 1.25 to the 23rd divided by 6.022 to the 23rd, and we get 0.208 mole of Mg. So what this means is that in 0.208 moles of magnesium, there are 1.25 times 10 to the 23rd atoms. Example 2. How many atoms are in 2.12 moles of silver? So in this case, we're going backwards. 2.12 mole Ag over 1 times, we're trying to go 2 atoms, 6.022 times 10 to the 23rd atoms are present in 1 mole. So 2.12 times 6.022 to the 23rd, we get 1.28 times 10 to the 24th atoms of silver. Mole canceling with mole, left with atoms. Propane is a gas used for cooking and heating. How many atoms are in 2.12 moles of propane? So we have 2.12 moles of propane over 1. And we have to keep in mind that C3H8 is a molecule, not an atom. So here we have 1 mole is equal to 6.022 times 10 to the 23rd molecules, because remember it can change, just like donuts is a dozen as well as eggs. And then within 1 molecule, yes, you have to write out molecule of propane, there are 11 atoms. All I did there was take 3 plus 8. So mole cancels with mole, molecule cancels with molecule. We're left with a unit of atoms. So 2.12 times 6.022 times 10 to the 23rd times 11 we get 1.40 times 10 to the 25, atoms of propane. And there you have it. So the mole and the dozen, how are they similar? So they are both quantities made of specified number of representative particles. A dozen of something equals 12 of that thing, and a mole of something equals 6.022 times 10 to the 23rd of that thing. So it's just another way to group things and make counting easier. And the reason this number is so large is because atoms, molecules, and ions are so tiny. The last thing we're going to talk about in this video is molar mass. The atomic mass of an element from the periodic table is expressed in grams, and that is the mass of 1 mole of the element. So the molar mass is the mass of 1 mole of that element. For example, carbon is 12.01, and we used to say AMU, but now we know that 12.01 grams is 1 mole of that element. So 12.01 grams equals 1 mole. So we can use this as our conversion factor. So from here on out, when we use the masses from the periodic table, like for example hydrogen, we will use 1.008 grams per mole. So how many atoms are contained in the molar mass of an element? Well, think about what we just said. Molar mass is 1 mole of that element. So how many atoms are in 1 mole? 1 mole, again, equals 6.022 times 10 to the 23rd atoms. So to find the molar mass, or to find the mass of 1 mole of a compound, you must know the formula of the compound, which is why we spent so much time figuring out formulas. So to calculate molar mass, it's quite simple. You're going to count the atoms in that compound. You're going to look up the mass of each element and multiply the mass of the element by the number of atoms of each element. Now that might sound like a little bit of work, but it is quite simple. So for example, the decomposition of hydrogen peroxide, H2O2, provides enough energy to launch a rocket. What is the molar mass of hydrogen peroxide? Okay, so all we need to do here is look at the formula, H2O2, and we add up their masses. So we have 2 hydrogens plus 2 oxygens. 2 times 1.008 grams per mole plus 2 times 16.00 grams per mole. So all we need to do is use our calculator and add these together, and we get a molar mass of 34.02 grams per mole. And that is for hydrogen peroxide. As always, all the information on these slides has been acquired and adapted from Pearson Chemistry, 2012 edition of the textbook, the resources CD, and pearsonchem.com. Have a great day.